Hello all, welcome to the Countingwell exam prep live session. Before we start the session, let me try to lift your spirit a little higher and boost your confidence a little bit. Always remember that the harder you work, the more luck you seem to have. We know that exam season is round the corner and the two most important factors of scoring good are revision and practice. Remember that practice doesn't make you perfect but helps you to perform better. Planning beforehand allows plenty of time for your revision, and so we are here to shoo away your exam fear and help you revise your concepts before it's too late. So, stay tuned to the session and build up the confidence to face your exams. In this session, I will take you through chapter Basic Geometrical Ideas from class 6. Let us see some basics of this chapter. Let us see some basic shapes. Let us see what is a ray. A ray is nothing but part of a line segment or a line starting at a point and extending in one direction endlessly. So if A is the initial point and B is any point on ray AB, so a ray is represented as ray AB. Let us see what is a line. Line is nothing but extending endlessly in both directions. For example, here we have line PQ. P and Q are points on the line PQ. Let us see what is a line segment. Line segment is nothing but a part of a line. For example, here we have XY or the line segment XY, where X and Y are the end points of line XY. Let us see what are pair of lines. Pair of lines can be parallel lines or intersecting lines. So lines which never intersect are parallel lines. It is represented using the symbol shown here. So we say line AB is parallel to line CD. Let us see what are intersecting lines. Two lines which intersect at a unique point are called intersecting lines. So we have lines AB and CD intersecting at point E. Note that the intersecting point of two lines is unique. That is, two lines always intersect at a unique point. So there cannot be more than one point of intersection. Also, we can have number of pair of parallel lines, or we have number of parallel lines. Also, for intersecting lines, there can be more than two lines intersecting at a same time. If there are two or more than two lines intersecting at a point, that point is again a unique point. Let us see what is an angle. An angle is nothing but formed with two rays starting from a common point. For example, here we can say the common point is O, and OX and OY are the two rays. So rays OX and OY form angle XOY at point O. Note that angle XOY can also be read as YOX, where A is called the vertex of the angle and OX and OY are called arms of the angle. So while you are naming the arms of any angle, you should name starting from the vertex of that angle. For example, here we have OX and OY. So you cannot name it as XO and XY or XO and YO. Let us see types of curves. Curve can be an open curve or a closed curve. A curve with different starting point and end point is called an open curve. For example, here you can see shape resembling letter L. It has two different points. One is starting point and one is ending point. So if you take the starting point as shown here, then the ending point will be here. Again, for the second figure, we can see if this is the starting point, then this will be the ending point. So the curve will be shown like this. It will be always open, having two different points. One will be starting point and one will be ending point. Let us see what is a closed curve. A curve with same starting point and ending point is called a closed curve. For example, here we can see one trapezium or one random or free form figure, which is closed curve or closed figure. So let us identify which are the open and closed figures among the following. Note that closed curves and open curves can also be called as closed figures and open figures respectively. For example, let us see the first figure. In the first figure, we can see the starting point and ending point are the same, or we cannot find which one is the starting and which one is the ending point. So it is a closed curve. For the second figure, we have a curve. We can see it looks open. So it has one starting point and one ending point. For the third figure, we can see we cannot find any starting point or ending point. So it is a closed curve or closed figure. For the fourth figure, we can see there is one starting point and one ending point. So it is an open curve or open figure. For the fifth figure, we can see we cannot find any starting point or ending point. So it is a closed curve. So the given figures are classified as follows. You can see the closed figures are shown here and open figures are these two figures as discussed. Let us see what are polygons. Polygons are nothing but closed curves or figures made up of only line segments. So you can see the polygons as shown here. Note that a triangle is also a polygon, a square is also a polygon, and so on. But whether a circle is a polygon? No, because it is not made up of line segments. Now let us see what are sides of a polygon. Line segments forming a polygon are called its sides, whereas line segments joining the non-consecutive vertices are called diagonals. So the diagonals are nothing but line segments joining non-consecutive vertices. So here if you can see a hexagon is there. So we can see there are 6 vertices, and let us see which one are the non-consecutive. So non-consecutive means the alternate vertices. So if we join these vertices, we can see we have obtained diagonals. Whereas there are 6 sides for this polygon. So vertex is mainly the point where the two sides of a polygon meet, whereas adjacent sides of a polygon are nothing but two sides which have a common vertex. The endpoints of a side of a polygon are called adjacent vertices, whereas the line segments joining non-adjacent vertices are called diagonals of a polygon. Let us see what are the types of polygons. First is regular polygons. Polygons with all equal sides and all equal angles are called regular. For example, square, equilateral triangle, regular pentagon, etc. You can see in the first figure, we have a square and the equal sides are shown like this, whereas as it has equal angles, so it is shown by the equal symbols or the same symbols. Then in second figure, we have one equilateral triangle having all the three sides equal and the three angles equal as well. In the third figure, we have a pentagon having all sides equal and all angles equal. Let us see what are triangles. Triangles are nothing but polygons with three sides, three vertices, three angles, and no diagonals. Note that a triangle cannot have a diagonal because there are no non-consecutive vertices. Next, we have quadrilaterals. It is nothing but polygons with four sides, four vertices, four angles, and two diagonals. There are two pairs of non-consecutive vertices. That's why we have two diagonals connecting the opposite vertices of that quadrilateral. So there will be two pairs of opposite sides, two pairs of opposite angles, four pairs of adjacent sides, or four pairs of adjacent angles. Now let us see what are the parts of a circle. A circle has a fixed point around which it is drawn called the center of the circle. Then we have radius of the circle. It is nothing but the line segment joining the center and a point on the circle. A radius is always fixed distance between the center and any point on the circle. Then we have diameter of a circle, which is the line segment passing through the center and whose end points lie on the circumference of the circle. So it is nothing but double of the radius. Also, radius is half of the diameter. Next, we have circumference. Circumference of circle is nothing but the length of the boundary. So here we can see a circle having its parts. The first is the center of the circle. Next, we have radius, which is a fixed distance between any point on the circle and the center. Next, we have diameter. You can see the diameter is the line segment passing through the center and endpoints lying on the circumference of circle. And circumference is nothing but the boundary of the circle. Next, let us see what is a chord. Line segment joining any 2 points on the circle is called a chord. So when can a chord and diameter will be same? Yes, when the chord is the longest one. Then we have the diameter. Longest chord is nothing but line segment joining the circumference of the circle, or line segment joining the points lying on the circumference of circle. So diameter will be the longest chord of the circle. Next, we can see portion of a circle called arc. So portion of the circle means portion of the circumference of the circle. Let us see what is a sector. A sector is nothing but part of the interior of a circle enclosed between two radii and arc joining the endpoints of the radii. So the sector here is shown by the highlighted blue color. So it is nothing but, if you take a pizza and the slice of a pizza will be the sector of that pizza. Let us see what is a segment. Part of the interior of a circle enclosed between a chord and a arc joining the endpoints of the chord is called a segment. So let us see what are some properties of parallel lines and intersecting lines. First of all, parallel lines never meet, whereas intersecting line meet at a point. Some may be on extending. Then parallel lines maintain a constant distance between them, whereas intersecting lines do not maintain a constant distance between them. For parallels, we do not have any common point, but for intersecting lines, we have a point in common, which is their point of intersection. So if you see, these two are intersecting lines. Also, these two are intersecting lines because they will meet at some point after they are extended in this way. Next, let us see some tricks for the exams for this chapter. First is two lines which are not parallel intersect at a point even if their point of intersection is not shown. So often students may get confused, like here we can see two lines which are not parallel, but they are not intersecting as well because they cannot find any point of intersection common. But note that these two lines are intersecting because though their point of intersection is not shown in the figure, but if you extend these two lines on the right, you can get their point of intersection as shown here. Now representing array. To represent a name of array, we should always mention the initial point or the end point of the ray first. So here you can see for the ray shown here, the end point is A. So while you are naming this ray, you should start with A, or you can call it as ray AB and not ray BA. So ray AB will always start from the point A, whereas the ray BA will start from the point B. Ray AB can be represented as AB with a small arrow overhead. Also, the starting point of the arrow over the letters indicate the initial point of the ray. So if you are not writing it as ray AB, you can write it with arrow over the letters. So the starting point of the arrow denotes the initial point of the ray. So when you're writing AB with a arrow overhead going from left to right, it means the ray starts from the point A and it extends towards B. So the same ray can be extended as BA, but the ray should start from right and extended to the left. It is not same as BA with a arrow overhead starting from left end and extending to the right end. So BA with arrow overhead in this direction and AB with arrow overhead going to the left represent the same ray BA. Or you can see the difference between the rays AB and BA as shown here. Let us see how to name an angle. If there are two or more angles formed at the same point, then mention all the three letters to specify an angle. The vertex of the angle should be in the middle. For example, here you have angles WHA, AHR, WHR. In the given figure, there are three angles formed at H. So to specify the marked angle, instead of writing H or angle H, we should write WHA or AHW. Or you can write AHR or RHA. Or you can write WHR or RHW. But you cannot name it as HAW or HRA like that. Or the vertex of the angle should be always the letter in the middle. Let us see, when we say a circle, it is just the boundary but not the interior of the circle. Consider a coin. A coin is not a circle. It is just, say, a coin has a circular shape. That is, its boundary is a circle. You can see when you say a circle, we do not consider the interior of the circle. We only consider the boundary of the circle. So a coin is in circular shape, or we can say a bangle is in a circular shape, or a pizza is in a circular shape. Let us see what are the some common mistakes the students can do. First common mistake is the same which we have discussed earlier about the parallel lines and intersecting lines. Even if you have a set of lines shown like this, you can see there are three lines parallel, and the fourth one is going in this orientation. So you can see these three lines are parallel to each other, but the fourth line is not parallel to these three lines. The fourth line will be intersecting to line 1, 2, and 3. So the number of intersecting points will be 3. So if you extend the first line, the second line, the third line, and then you extend the fourth line as well, then you can see the fourth line intersects the three lines in three different points or three unique points. So the line 1 and 4 will intersect at some point which will be unique. Let us say it as A, point A. Line 2 and 4 will intersect at some other unique point which is point B. Line 3 and 4 will intersect at some unique point called C. So in this way, you should always note that when the point of intersection is not shown in the figure, then also if the lines are not parallel or the distance between the two lines is not maintained, then we say those lines are intersecting lines. Also, while representing a ray, you should take care about the endpoint of the ray and towards which point the ray is extended to. So you can see B here is the end point. So you cannot extend the ray from the point B. You can extend the ray using point A endlessly. So there will be no end for this extension. And whenever you are naming the ray or representing the ray, you should write the endpoint letter first and then the point of extension next to that endpoint. So we have ray BA or BA with the arrow overhead starting from the letter B or the left end to the right end. Next, one thing is about the naming of an angle. As I've told you, instead of writing only angle H, you should specifically mention about which angle you are talking about. So if you're talking about the angle shown here as 30 degree, then you should have WHA or measure of angle WHA equals to 30. You cannot write angle H equal to 30 because you have to specify which angle you are talking about. Next, always consider a circle with its boundary. Or whenever we say circle, we are talking about the boundary. So whenever we are describing the shape of any object, we describe it as whether it is circular in shape or triangular in shape, etc. So for any object having circular shape, we note the boundary of that object and not the interior. Now let us see some exam tips for this chapter. You should practice a variety of questions from NCERT textbooks, exemplar and other textbooks from previous year question papers as well. You should note down all the definitions and properties separately to glance at before you are going to attend the test. You should also identify the properties of the figures that need to be applied or checked. For example, the properties of equilateral triangle. An equilateral triangle has all three sides equal and three angles equal. So if you are given the measures of any two angles, you can find the third angle using the property that the sum of all the angles of a triangle is 180 degree. Next, you should always read the given question carefully and understand it. At the last, you have to check whether you have answered all the questions and parts of the questions correctly. I hope this session was helpful. And if you want to quickly revise the concepts, practice some extra sums, and also take a quick test, Countingwell exam pep kit is here, and it lets you to quickly glance through the major concepts of your chapter. You can also glance through solved examples, practice questions, and chapter assessments. You will also understand the tips and tricks, common errors that you make, etc. Over 75,000 students trust Countingwell for their maths learning, and even without the exam prep kit, they can learn every day on the app by diving deep into every chapter. You can download the app from App Store or Play Store. Also, stay connected to our channel Countingwell and learn more tricks and tips and ways to avoid common mistakes. We will be revising the chapters polygons and quadrilaterals, practical geometry from class 8 in our next live session on 7th February, that is Monday at 6:30 p.m. Well, see you in the next session.